Okay, so for example number 13, so if you have seen the diagram or the picture, okay, so we are given here f sub 1 and f sub 2, okay, but f sub 2 is the unknown. We are asked here for the magnitude of the f sub 2 as well as the coordinate direction angles of that f sub 2. So we will be solving the alpha, beta, and gamma of your f sub 2 as well as the magnitude. The given here is the magnitude of f sub 1, which is 300 newtons, as well as the coordinate angles of your f sub 1, which is as you can see, the 45 degrees here is measured from the x-axis, so this is our alpha. The 60 degrees is measured from the y-axis, so that's our beta. And the 120 degrees is measured from the z-axis, so that's our gamma. Also class, the resultant force of f sub 1 and f sub 2 is given, which has the magnitude of 800 newtons, and take note, it is along the positive y-axis. So what does that mean? Okay, what does that mean? That means, class, since it is exactly on the y-axis, which means that it doesn't have x and z components. Take note, it is only at the positive y-axis, which means that this 800 Newton, okay, if we express that in Cartesian notation, so that would be 800 J Newton. Can you follow? Kasi exactly andun siya sa y-axis eh. So which means that its x components and z components are 0. Okay? So therefore, since positive, so positive J. Okay? So this is our resultant force. Now, we are asked to solve for the f sub 2. Now, based from our vector addition, okay, so f sub r is simply the sum of f sub 1 and f sub 2. Okay, now, given the f sub r, which is this, so we have to solve for f sub 2 by subtracting f sub 1 from f sub r. But we have to express first our f sub 1 in the Cartesian vector notation. Now, given the magnitude as well as the, what we call this, direction angles, so we can express our f sub 1, okay? So, f1x, I, f1y, j, plus f1z, k. Okay? So, these are its x component, y component, and z component. Now, recall that you'll be able to solve for the x component using the formula cosine alpha is f1x over your magnitude. So, this is your f sub 1. So, this should be absolute value. So, using this formula or using this value here and this magnitude, so we'll be able to solve for your f1x by simply multiplying your magnitude, which is 300, and then cosine your alpha, which is 45 degrees. Okay? As well as class, for your y components, okay? So, the same formula, papalitan lang natin yung subscript niya and the angle, of course. So, for the f1y, so, the magnitude times the cosine of your beta. Beta naman sa y component. So, the beta is 60. And for the z component, that is 300 cosine your gamma, which is 120 degrees. Okay, so using your calculator, how much are this? So, we have 300 cosine 45. That is 212, 132. This, the unit is in Newton. We also have 300 cosine 60, 150. And we also have 300 cosine 120. We have negative 150 Newton. Okay? So, using these values, we will substitute it here so that our f sub 1 is expressed in Cartesian vector notation. So, may I erase this one? I'm gonna erase this. So, substituting, okay, so your f sub 1, so f1x is 212, 212, 132, and then it is I plus 150 J minus 150 K. And the unit is Newton. Okay? So as you can see, this is our F sub R, this is our F sub 1. So we can now substitute here. Okay? So F sub 2. So F sub 2 now. So substituting your F sub R, which is 800J. So 800J. And then minus, copy the minus, and then copy the value of f sub 1, which is 212.132i plus 150j minus 150k. There. So take note that they have the same unit, Newton and Newton. So therefore, the quantity here is Newton. Okay? Now, we will now combine like terms like we have said. So in this case, we don't have other I, only the 212. So negative times 212. So therefore, that is, can I erase this one? So your f sub 2 is negative 212.132i. Okay? You combine j, so 800 minus 150. Take note that negative class will be distributed in the entire parenthesis. So 800 minus 150, 650. So positive 650J. Okay? And there's no other K but this one. So negative times negative, that will become positive. So positive 150K. Okay, so this is our f sub 2. But this is not yet the answer, class. Why? It's because we are asked for the magnitude. Okay, it's the magnitude that we are asked for. So, solving for the magnitude, can I erase this one? The magnitude is f sub 2 equals square root of the x component squared, y component squared, and z component squared. There. Okay? So, substituting, your x component here is this negative 212. So, negative 212.132 squared plus your y component is 650 squared plus z component is 150 squared. There. So using your calculator, square root of 212.132 squared plus 650 squared plus 150 squared. Let us check. 212, 132, 650, and 150. 699. 699, 99.999, or this is already 700 class, 700 newtons. Take note, this is our magnitude of your f sub 2. So this is already answer, class. But as we have said, in the given, in the problem, we still need to solve for the coordinate direction angles. So we still be solving for alpha, beta, and gamma of your f sub 2 using this equation here. Okay? So using your cosine alpha. So you have here the f2x over your magnitude. Okay, so your x component here, take note that we will only get the absolute value. So our cosine f2x is this negative, so absolute value is 212.132 over your magnitude, which is 700. There. So your alpha will become arc cosine 212.132 over 700. We have 72.359 degrees. This is already answer, class. While for the beta, we have beta is arc cosine, so y component over magnitude of your f sub 2. So arc cosine 650 over f sub 2 is 700. So arc cosine 650 over 700. There. We have 21.787 degrees. 21. Answer already for the beta. And lastly, for the gamma, I'll just use this one. So gamma is arc cosine. So the z component, 2z over your f2. So this will be, z component is 150 over 700. Okay? So this is arc cosine 150 over 700. You'll have 77,626 degrees. 77,626. Okay. And this is already answer, class. So this is your magnitude and these are your coordinate angles, alpha, beta, and gamma. And that's it for the solution for example number 13.